Today we will see what is SN curve. SN curve is a graph that represents the relationship between the applied stress range and number of cycles. It is between the stress range and number of cycles. It will have two branches. One is m equal to 3, another one is m equal to 5. This is the low stress cycles and this is the high stress. You can see high stress is these things are high stress cycles, and this region is high stress cycles and this region is low stress cycles. Okay, let's see. So this is the relation between the applied stress range and number of cycles to failure. Number of cycles to failure for a material. It helps predict how long a material can last under cyclic loading. So it is helping us to predict how long the material can last under cyclic loading. This is also important under cyclic loading. So what does n represent in the SN curve equation? This n represents the predicted number of cycles to failure for a material under specific stress range. So under this specific range, how many number of cycles are required? Like that we can predict the number of cycles to failure for a material. What is the formula for basic design of SN curve? This is a formula: logarithmic n equal to logarithmic k1 minus m into L. Log yes, m is the slope, m equal to 3 here, this is m equal to 5. So where n is the number of cycles, k1 is a constant, m is the slope of the curve, s is the stress range. What does s represent in SN curve? What does s represent? Here we see what does n represent, here we will see what does s represent. S represents the applied stress range, or a difference between the maximum and minimum stress in a loading cycle. What is the significance of the constant k1? The significance of constant k1, here there is a constant k1, is that right? What is the significance of this? K1 is a material specific constant that reflects the inherent strength and fatigue resistance of a material. So that is a material specific. So that is material specific constant and reflects the inherent strength and fatigue resistance. How does the slope m affect the SN curve? The slope m determines how quickly material fails as the stress range increases. You see here, this is the SN curve, right? This is m equal to 3, this is m equal to 5, right? This region is m equal to 3 and this region equal to m equal to 5, right? This m equal to 3 and this equal to m equal to, yes, this is the stress range, this is the number of cycles. So m, the slope m determines how quickly the material fails as the stress range increases. A higher m, this higher m means a steeper curve, indicating a material will fail more quickly under high stress. Material will fail more quickly under high stress. What is the typical value of m for welded joints, low cycle fatigue? Low cycle fatigue welded joints. Like for welded joints, the low cycle fatigue n less than equal to 0 is typically m equal to 3. For welded joints, we can see it here. So welded joints, low cycle fatigue n less than 1, value of m is typically 3. How does the value of m change for higher cycle? N is greater than 10 power 7. For higher cycle, the value of m generally changes to 5. What is the reference thickness for welded joints? The reference thickness for welded joints is 16 mm. How is the stress adjusted for materials with the thickness greater than the reference thickness? The stress is adjusted like s equal to s naught into t ref by t, 1 power 0.25. S is the stress from the SN curve. S naught is the stress from SN curve. T reference is the reference thickness, T is the actual thickness over here. What happens if the weld has profile control or is ground or pinned? If the weld has profile control or exponent thickness adjacent to the formula changes to 0.2. If the weld 2 is ground or pinned, the exponent changes to 0.15. Instead of 0.25, that changes to 0.2 and 0.15 based on whether the weld has profile control or is ground or pinned. What is the reference thickness for cast joints? That is 38 mm. How is the stress adjusted for castings with thickness greater than the reference thickness? The same way, it's a 0.15 is the exponential term. What happens if the material thickness is less than the reference thickness? If the material thickness is less than the reference, then no adjustment is made to the stress. What is the impact of seawater on welded joints? For welded joints exposed to seawater, adequate cathodic protection, m equal to 3 branch of the SN curve is reduced to a factor of 2, while the m equal to 5 stays unchanged. Branch remains unchanged. What is the effect of corrosion protection on SN curve? A proper corrosion protection helps preserve the material's fatigue life in seawater, but joints without adequate corrosion protection may experience reduced fatigue life. When do we use WJ curve? When do we use CJ curve? WJ curve is used for welded joints and the CJ curve is used for cast joints. What is the main difference between the SN curves of welded and cast joints? The difference lies in the reference thickness and the exponent for adjusting the stress based on thickness. Cast joints used as a reference thickness of 38 mm as exponent 0.15, while welded joint uses 16 mm exponent 0.25. What are some of the factors that must be considered when using SN curves in real-world applications? Factors such as material type, weld quality, thickness, and environmental conditions, seawater exposure, presence of corrosion protection must be considered to ensure accurate predictions of fatigue life. What is the significance of the table 8.2 in the context of SN curve? That's a basic SN curve for welded joints and cast joints, along with corresponding values of K1 and M, which are used to predict the fatigue life of joints in different stress scenarios. These questions and answers cover the key concepts and technical details behind the SN curves for tubular joints.